lesson? 9.5. All of 9.5 today. We will review on Monday, and we will test on Tuesday. Okay, so this is geometric series. So you know what a series is. What's the difference between a series and a sequence? Anybody know? What does a sequence have between numbers? Commas. What does a series have between numbers? Addition sign. Perfect. Okay, so let's go ahead and start with just a geometric series. So we did arithmetic already. So here we go. A geometric series, we're going to actually have two sum formulas. They're up here. I'm going to show you what the difference is for two of them. So if you have a sub 1 plus a sub 2 plus a sub 3 all the way to a final term, okay? That is a finite series. And let's say that this is a finite geometric series. Okay, so if you're adding up a finite number of numbers, so 10 numbers or 20 numbers or 30 or 12 or whatever, then, and it's a geometric sequence that you're doing, then what you want to do is this formula. The sum of n numbers is equal to, and this is what I like to write, it's going to be a sub 1 times 1 minus r to the n over 1 minus r. Write it down like that. The book does not have all those parentheses there, but I do that so that you'll put it into your calculator correctly, okay? Because you're going to need parentheses around that and around the bottom, and that's what it looks like. So there it is. Do you have to memorize that gross formula? No, you don't. Okay? You need to know what some things are, though. You need to know that a sub 1 is the first term. First term. Okay? You also need to know that r is the common ratio. Remember with the geometric series or sequence, it's a common ratio. It's the number you multiply by each time. And then n is what? The number of terms that you are adding up. Number of terms. Okay. Are you ready to do one? Yes. Okay, number 1.
I really appreciate you putting all the formulas on there.
Oh, thank you. Yeah, I really don't want you to have to memorize all that. It's terrible. Okay, let's go ahead and evaluate this sum. And I'm going to show you how to do it 2 ways. Evaluate. 3 plus 6 plus 12 plus 24 plus 48 plus 96. All right. 2 ways to do this. One way is to get your calculator out and plug those numbers in. And that would be fine. There's not that many of them. Why not do it that way? And you could, okay? I'm not saying you can't. And actually, I prefer if you did that, then you're not getting all confused. The other way is to use a sum formula. And I'm going to teach it that way because you might have 20 terms you have to add up instead of just a few. So what you need to do is you need to decide, what is this? What kind of a sequence of numbers is this? Is it arithmetic or is it geometric? Well, what's happening each time? Adding? Adding 3, oh, but then 6 to 12. So it's multiplying by 2. Okay? It's multiplying by 2 every single time.
So what's the pluses?
Pluses, that's arithmetic. Oh, the pluses? No, it's adding each of these numbers, but to get from 3 to 6, 6 to 12, like ignore the pluses and see what kind of a sequence it is. Okay, now we're going to plug this into a finite geometric sum. We're not going to do arithmetic sum because that's for an arithmetic sequence. We have a geometric sequence going on here. So here we go. And take your calculator because I want you to practice this. So we're going to add up the sum of a finite number. And here's the formula right here. A sub 1 is 3 times 1 minus 2 to the what power? Remember what n stands for? N stands for the number of terms that I'm adding up. Did you count? Yeah? 1, 2, 3, 4, 5, 6. So to the 6th power, all over 1 minus 2. Okay, so I used that formula right here at the top of the screen, and I plugged in the first term for A1. I plugged in R is 2 and N is 6. Now, when you put this in your calculator, you can put it in just like that. You go to your calculator and you go 3 parentheses, 1 minus 2 to the 6th power, close the parentheses, divided by parentheses 1 minus 2. 189. Did you get that? 189. Perfect. And if you were to add those numbers up on your calculator, which wouldn't take too long, you'd get 189.
Can you do that on home base?
Yeah, you could. You could. Now, the problem is if you get something like this, number 2. Suppose that
If you like just took the time to like add them all up,
Mhm.
you would get it right every time.
You would. Yep. The thing is that I wouldn't make, like, you wouldn't want to do that if there were 50 numbers to add up.
But I want to secure a good grade.
I know. And it also, quizzes and tests have a time limit. So, okay. Let's try this one. 4 plus 12 plus 36 plus ... And we want to find the sum of the first 10 terms. Okay? Sum of 10. Now, this is kind of a cooler formula. The other one, the arithmetic, we had to know the number of terms, the first term, and the last term. We don't need to know all of that stuff for geometric. So let's do it. We're going to find the sum of the first 10 terms, and we're going to plug it into our formula. Now, you could, if you wanted to, write out all 10, but guess what? I would not suggest that. These numbers are going to get bigger and bigger and bigger because we're multiplying by what each time here? 3. So it's going to be a huge number at the end. I'll show you. So a sub 1 is 4 times 1 minus r to the n. I'm using this formula right here. A sub 1 is 4. 1 minus r to the n would be 1 minus 3 to the 10th power all over 1 minus 3. Formulas are so nice, aren't they? Don't you just want to thank the people that came up with this?
Yeah.
So now you get to do it?
They're why I need to learn.
Yes, true. And who decides what you need to know? What'd you get? You got a pretty big number. I wouldn't want to plug all these into my calculator to get 118,096. Ooh, that was my salary last year. Just kidding. But I'm bummed. That's fun. Okay. You're like, what? All right, now try this one. Number 3. There he is again. Good old friend Sigma.
Hi, Sigma.
Hi, Sigma. What's up? All right, Sigma is n equals 1 to 5 for, let's do 2 to the n. Now, here's another one of those that, you know what? If you wanted to, you could just write it out. There's only 5 of them. They might get a little bit big. So I'm going to show you 2 ways to do this. First thing you can do, you plug in 1. What's 2 to the first power? 2. 2 squared? 4. 2 cubed? 8. 2 to the 4th? 16. And 32. Why would I want to use a formula? I wouldn't. I would just add those up. Okay? I would add this up. I wouldn't even need a calculator. Watch. Add up 2 and 8, and you get 10. Add up 4 and 16, and you get 20. So the answer is 62. Didn't need a calculator for that. Okay? So sometimes you do, sometimes you don't, and that might be a hard thing to like remember. But if it's only 5 numbers that you're adding up, why not just add up your 5 numbers? All right, let's move on to part B. Here comes the last formula for this chapter. We're going to talk about an infinite geometric series.
Is there a part C?
There is. Infinite geometric series. Yeah. Okay, this is going to get us ready for part C. Part C is the best part of the day.
Really?
Mm-hmm.
Like, promise?
Yes. All right, so you know what an infinite series is. It has the ... at the end, and it goes forever and ever. So, like, for example, if you had something like this, 5 plus 10 plus 20 plus 40 plus 80, ... Okay? Those numbers are getting bigger and bigger and bigger, right? They're multiplying by 2. So r equals 2 here. What's happening is the sum is going to go off to infinity. It's going to just go off to infinity if you keep going forever and ever. Now let me show you one that's a little different. It looks like this. If you have something like 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus ... This one actually is going to converge. It's called Converge. We're going to write that down in a minute. And the sum of this is actually going to be 2. Do you believe me? How can I add up an infinite amount of numbers and get one solid finite number? Let me show you this in a picture form, okay? Do you see this 1 right here? What if I had one circle? One whole circle, okay? And then I'm going to add it to half of a circle. And then I'm going to add it to a quarter of a circle. I'm going to add it to an eighth of a circle and a 16th. And if I do that an infinite amount of times, I know infinity is a really hard thing to think about because we don't know infinity in our real life world. If I did it an infinite amount of times, it will actually fill in that entire circle, giving me 1 plus 1 is 2. If I'm short, if I'm just before infinity, there's a little sliver still there. But because I'm taking this all the way to infinity, it fills the whole thing in. Isn't that cool? No?
So 2 circles equals 2.
Yes, in a way. Okay, so there's 2 types. There are going to be infinite series that converge. Okay, so write that down because you're going to need to know that. These are going to be the numbers that are pretty big when numbers that are like smaller fractions. Like anytime you have an absolute value of r is less than 1, that means that r is between -1 and +1. These will converge. What that means is that you will have a sum. Your sum, they call it just S, okay? Those are the ones that converge. That's like the last one I did. It actually has a sum. The sum was 2. Then there's going to be the opposite of converge. You know what the opposite of converge is? Starts with the D. Diverge.
Divergent.
Yes, divergent. All right, so you diverge when the absolute value of r is greater than or equal to 1. So if it was 2 or 20 or whatever, big numbers, then the sum is going to go off to infinity. Okay, there's no limit. So let's look at this. All you have to do is look at r. Ooh, think of it this way. I didn't think about it this way. You know how geometric, these are exponential, right? If I have an exponential graph that looks like this, do you see how it's going up to infinity forever? It means my numbers are getting bigger. This is exponential growth. And do you remember what exponential growth was? It was bigger than 1. Remember that? And remember decay? Like half-life was decay. So if you have a decay, it looks like that. Okay, and then they're going to converge to a number. All right. I don't know if that helps. So here we go. What are we on? Number 4. Number 4 has this. It has a 2 plus 2/3 plus 2/9 plus 2/27 plus ... And the question is, it doesn't ask you to find the sum of it. It just says, does this converge or diverge? Okay, those are pretty fancy words, right? Now, all you need to do is find out what r is. And if r is, a small fraction, not like 5/4, but 4/5 or something, smaller fraction than 1, then it's going to converge. So what is r in this case? What is this multiplying by each time in this sequence? 1/3. Perfect. r is 1/3. 2 times 1/3 is 2/3 times 1/3 is 2/9, so on and so forth. So r equals 1/3. So will this series converge or diverge? It will converge. It converges to a number, a sum. It actually has a sum.
Can you explain that?
So these are getting smaller and smaller and smaller, and these numbers are all going to 0, pretty much. Like they're going to get to 0 at infinity, so it will have a sum. The sum's not 0 because you're adding up 2 plus 2/3 plus 2/9. So R is between -1 and +1, it will converge. So R is 1/3. 1/3 is between -1 and 1, so this series converges. All right, let me show you the other kind, one that diverges. Suppose you have this. You have the summation from n equals 1 to infinity. Ooh, I put a little infinity symbol up top. It's kind of ugly, though. Let me rewrite that. Are you laughing at my infinity symbols? Yeah, it's bad. Still gross. And let's say this is 3 times 4 to the n minus 1. All right. They're asking you not to find the sum, but they're just asking you, does this converge or diverge? Now, there's a lot going on here, right? You've got a sigma, you've got an infinity symbol, you've got exponents. This is all you need to look at. Right there. That number 4. Okay? So if I'm multiplying something by 4 each time, are those numbers going to get super big or super small? Super big, right? So this right here, R is equal to 4. You can tell, look at that formula up there. A sub 1, R to the n minus 1. A sub 1, R to the n minus 1. R equals 4. This is going to diverge. Diverge. The sum's going to go off to infinity. Okay, so now what happens when your series converges? This brings us to the last and final part, part C. Here we go. Last part of the whole chapter even. All right, we're going to talk about infinite series. All right. So, if your series converges, then here comes the last and final formula. Then the sum of the infinite numbers, and this only works for geometric. Do you see how I put an X on the board? Arithmetic has no infinite sum. The sum will either be infinity or negative infinity. But here, if it converges, so your series has to converge, then the sum is equal to the first term over 1 minus R. Look how nice that is. See how gross the finite one is? This is us. We're finite. God's infinite. Look how perfect and pure that is. It's nice, huh? All right, there it is. So let's do a couple of these. Number 6. Number 6. Okay. Suppose that I'm going to add up, what's a good one? Here we go. Suppose I'm going to add up n equals 1 to infinity of 1/5 to the n minus 1. Okay? Now, you think, oh, it's going to take us forever to add up an infinite amount of numbers. Get it? Because infinity? Anyways. So what you want to do is you want to use your formula. First, you have to check if it converges. So you want to now look at what R is. R is 1/5. That will converge. Okay? If it's between -1 and +1, it will converge. Now, take a look at what these numbers look like. If I plug in 1 into here, I get 1/5 to the 0 power is 1. If I plug in 2, then I get 1/5. What's happening is this is adding 1/5 every single time, so these numbers are getting smaller and smaller and smaller. So then the sum of the infinite amount of numbers here would equal, I'm going to use this formula right here. A sub 1, when you plug in 1, you get 1. A sub 1, the first term is 1. And then divide it by 1 minus R. Okay, put this in your calculator exactly like that. Go to your calculator and do 1 divided by parentheses 1 minus 1/5. Close parentheses. The answer is 1.25. Isn't that so cool?
Yeah.
All right, let's try another one. Number 7. Ooh, I love this one. This one's really good because this one you actually can see what's kind of happening here. Let's go ahead and add up 1/3 plus 1/9 plus 1/27. Did I do that right?
Yeah.
Plus dot, dot, dot. Okay. Let's see what this is equal to. Now, we can see here that our r is 1/3. So this will converge. We can get the sum of the infinite numbers. So s of infinity equals, use the formula. First term is what? 1/3?
Yes.
Over 1 minus 1/3. Ooh, 7 minutes. Because we're multiplying by 1/3 each time. So if you're going to plug this in, go 1 divided by 3 divided by parentheses 1 minus 1/3. This is equal to 0.5. Isn't that cool? That equals 1/2? That's so cool. How about this one? Did I say one more? Oh, sorry. How about 0.3? This one you can actually think about logically. Plus 0.03 plus 0.003 plus dot, dot, dot. Okay, because some of you might be a little skeptical. There's no way you can add up an infinite amount of numbers and it equals one number. Well, it does. So if I did this, watch, and if I wrote this differently and I wrote 0.3 plus 0.03, 0.003, and I added these, what am I getting? 0.33333. What is 0.3 repeating? 1/3. This equals 1/3 up here. You want to test it? Sum of the infinite numbers is a sub 1 over 1 minus r. What's r here? What's this multiplying by each time? Do you know? To go from 0.3 to 0.03? Do you know what that is? You would take 0.03 and divide it by 0.3, and it's 0.1. It's just 1/10 each time. So minus 0.1. And do that in your calculator. So 0.3 divided by 1 minus 0.1, and you get 0.3 repeating, which your calculator and you know is 1/3. All right.